Let's look at this question. D1, D2, D3, D4, D5, so on are 12 districts in 3 states, namely S1, S2 and S3 in a country named mainland. Sugarcane is produced only in these districts of mainland. The following table gives information on the total production of sugarcane in the 12 districts of mainland and expressed as a percentage of total production of sugarcane in the country. Okay, so I have data regarding D1, D2 and so on till D12, and the percentage share that they have in sugarcane production is also mentioned in front of me. Okay. The following table gives information on the total production of sugarcane in the 3 states of mainland when expressed as a percentage of total production of sugarcane in the country. Okay. So I have the names of the state and the percentage share that they have in production as well. It is known that each state has exactly 4 districts out of the 12 districts mentioned. Each district can lie in only one state. Now, a good thing to notice is the first 3 questions start off with the word if. It means multiple cases will be possible. And even within the data given here, can you see that this data appears to be in a sequence where this is the highest, this is the middling value, this is the lowest. So the first thing that in order to make our base case, what we should do is put all the smallest possible numbers here, smallest possible numbers, highest possible numbers, and the middling numbers here. Let's say 47 gets created with, not 47, but the 4 largest numbers are 14, 13, 12 and 11. Let me just write them next to it. 14, 13, 12 and 11, and the smallest numbers are 2, 3, 5 and 6, 2, 3, 5 and 6, and the numbers that are left are 8, 9, 10 and 11. No, 11 is already used up. So the numbers that are used are 7, 8, 9 and 10. 7, 8, 9 and 10. It may appear why am I doing so, but there will be a purpose behind this. If you add up the numbers for state 1, the way we have written it down, it is 50. For state 2, the numbers add up to give me 34, and for state 3, the numbers add up to give me 18. Okay, so sorry, this adds up to give me 16. So as of now, this has a deficit of 2, this has a deficit of 1, and this has a surplus of 3. So whatever readjustment has to take place within this itself. Okay. You can either start from state 1 and move to state 3, or start from state 3 and move to state 1. I am choosing to go from state 3 to state 1. Just see. Right now there is a deficit of 2. If I want to adjust this deficit of 2, if I replace this state with production of 2%, I will need something with 4, but there is no 4 available. So this is not shifting anywhere. If I wanted to shift this 3, I would need a 5, but 5 is already present here, so this is not possible. If I want to shift this 5, I should get a 7. Yes, this is possible. So let me just record it. I would have for S1, S2 and S3, a base case that I can work with is 14, 13, 12, 11. 5 and 7 are exchanging. So I will have 10, 9, 8 and 5, which will give me 6, 7, 3 and 2. This ensures that S3 becomes 18, but still right now S2 would be at 32 and S1 would be at 50. S1 has 3 extra, S2 has 3 lesser than what it should be. So I have to shift things from S2 to S1 with a difference of 3. If I want to shift 5 from S2 to S1, I will need an 8. 8 is not present here, in fact it is present here itself. But this 8 can be replaced by this 11. This 9 can be replaced by this 12. And this 10 can be replaced by this 13. So effectively I'm getting 3 cases right now. Let me record those cases. I have 14, 10, 12, 11, 13 would go here, 13, 9, 8, 5, and 6, 7, 3, 2 remains constant. The other case would be 14, 13, 9, 11, 10, 12, 8, 5, 6, 7, 3, 2, and the final case would be 14, 13, 12, 8, 10, 9, 11, 5, and 6, 7, 3, 2. So we've got 3 cases from the situation where I was replacing this 5 with this 7. This is not the only way forward. I can also replace this 6 with this 8, which would lead me to a base case of 14, 13, 12, 11, 10, 9, 6, 7, 8, 5, 3, 2. Again, I'm reaching a total of 18 here. I'm reaching a total of 18 here. But here I'm reaching a total of 32, and here I'm reaching a total of 50. So I have to shift something from S2 to S3 so that a rectification of 3 happens. If I shift 7, I need a 10. 10 is already present here, so this does not work. If I shift 6, I need a 9, which is already present here, so this does not work. But I can change 9 with 12, and I can change 10 with 13. So I should get 2 more cases. Let me record those 2 more cases. I will have 14, 10, 12, 11, 13, 9, 6, 7, and 8, 5, 3, 2. The other case would be 14, 13, 9, 11, and here I would get 10, 12, 6, 7, and 8, 5, 3, 2. So this is the first case, this is the second case, this is the third case, this is the fourth case, and this is the fifth case. Now I have all 5 possible cases where shifting can happen. Let's get to the question. If district D3 is in state 2, D3 is 11, 11 is in state 2, 11 is not in state 2 here in case 1, 11 is not in state 2 in case 2, 11 is in state 2 in case 3. So as of now we are talking about this case. Not in 11 is not in state 2, 11 is not in state 2. So we are talking exclusively of case 3 right now. Which state is district D10? D10 is 8. Where is 8? 8 is in state 1, and therefore the answer to this question has to be A, state 1. Let's go to question number 2. If district D8 is in state 2, D8 is in state 2, 7 is in state 2, 7 is not in state 2, 7 is not in state 2, 7 is not in state 2, 7 is in state 2, 7 is in state 2. Okay, so cases 4 and 5 are being considered right now. Which state is district D9 in? D9 is 10. In case 4, D9 is in state 1. In case 5, D9 is in state 2. We are getting multiple answers, and therefore the correct answer here has to be option D, indeterminate. Let's go to question 3. If the district D2 is not in state 2, D2 is not in state 2, as in 6 is not in state 2. 6 is not in state 2, 6 is not in state 2, 6 is not in state 2, 6 is in state 2, 6 is in state 2. So Right now we've narrowed it down to either case 1 or case 2 or case 3, and the district D5 is not in state 1. D5 is 12. 12 is not in case 1, case 1 is eliminated, D12 is not in state 1, 12 is indeed not in state 1, so this is fulfilling the criteria. 12 is in state 1, this is not fulfilling the criteria, so we are exclusively talking of case 2 now. Which state is district D9 in? D9 is 10. Where is 10 in case 2? It is in state 2, and therefore the answer to this question has to be option B, state 2. Now question number 4. For how many districts out of 12 can the state in which they fall can be uniquely determined? Okay, so whatever numbers stay there guaranteed, we will not talk of them. If you notice, 10, 9, 8, they are shifting their places. So is 5, so is 6, so is 7, so is 13, so is 12, so is 11. The districts that will definitely not change their shapes have to be at the extremes. If you notice, this 14 here, this 3 here, and this 2 here, this remains constant. Regardless of the case that you take, they will never change their position. They will remain in 14 will remain in state 1 and 3 and 2 will remain in state 2 respectively. And therefore, for how many districts out of 12 can the state in which they fall can be uniquely determined? The precise answer is 3. Among these options, what we would mark is option D, and that has to be our final answer. The beauty in this question, or the logic in this question, is simply you have to check for extremes. Look at the extreme cases. This was our starting point. Once you make the extreme cases, then adjusting and making the future further possible cases is easy. Otherwise, you end up in a loop, and don't randomly try to pair numbers together to reach up a total of 47, because you might end up at one of these cases. But given that question starts off with if, it means multiple cases are possible, and you have to make sure all possible cases get covered. If you write it down in a logical way, all possible cases will indeed get covered.